So welcome back, everybody, and thank you for being here and listening to my story. So my name is Devis Tuia, and I work from EPFL Palais, so in Sion. And I want to show you a little bit the activities of my laboratory, which is called ECO, and go through a couple of examples of our activity and see how the different things that we have done and we are doing currently could then be interesting for some of the projects in the food industry, of which I'm not entirely really aware of, but I think that there are some interesting connections to be done. Okay, so 2 words about the lab before we go on the project themselves. So ECO stands for Environmental, Computational Science, and Earth Observation. So it's really a laboratory that puts together these 3 components. So the environmental one, the machine learning, computer vision through the computational science, and Earth observation. So as the image on the right show, we work a lot with satellites, with drone data, and everything that can be imaged from space or from the air. It's a relatively young lab. It started in September 2020, and as I see our mission, it is in 3 steps. So the first one is to monitor planet Earth with Earth observation technology, so remote sensing, from the smartphone images up to the satellite images that are acquired from space. Secondly, the more computer vision-y one, which is developing fair and transparent machine learning technology. I will come back to that, especially on the explainable AI angle. And finally, the third and more probably the most important one of these three aims is to serve applications with high impact on society. And this is where I will focus the rest of the presentation on examples of this application that concern our overall global case study, which is Earth. So this is basically our playground, let's say, in terms of monitoring. And there is a number of things that we can observe when we image planet Earth, and everybody will have a different one. So there are some that are maybe more concentrated at our latitudes, and they can be very, very different. For example, monitoring glaciers, and the one on the right, so the agricultural monitoring, that is probably the closest to the food industry that I have in our applications. I'll come back to that in a second. And then, but we can also have other field of study that will be biodiversity. This has been mentioned by in a couple of presentations before. So I work a lot in animal conservation and floral and faunal monitoring, deforestation, or all kind of land planning actions that can definitely be related to the agricultural industry and the preservation of biodiversity again. Forest fire, which is something that is very often in the news, let's say, and has a very big impact on society, and also, I suppose, on the production lines of several of your products. If there is a fire that burns several crops or trees, it might possibly impact your supply chains. And in the end, we also work on coral reefs. That's a little bit maybe more far away from what you do, but still it is one of the big challenges of our time, especially in terms of biodiversity loss, because coral are basically very interrelated with fish, and fish is basic for a big amount of our nutrition system. Okay, so you see, there is a wide variety of problems that we tackle at ECO, always with this satellite imaging perspective, and I decided to pick up 3 of them in this 10 minutes we still have together. So the first one is one of the main topics that we have in my lab, which is animal conservation. And I think this picture says about most of our activities, which are given an imaging support that is more often a drone, but can be an aerial sensor. Satellite, not so much. I mean, it needs to be for very big animals. I mean, are we able to first image a territory, and secondly, monitor and detect animals on the ground? which means developing computer vision-based systems that are able to detect objects that are at a relative distance and with high accuracy and minimal human supervision. So I decided to show this because I think that there is a little bit of overlap here with the food industry in terms of detecting fruits, for example, before harvesting, or all kinds of livestock that can be monitored for all kind of actions afterwards. But it's not only about computer vision and pure detection. There is something that I've been very active in the last few years. It's in developing solutions for human-machine interaction, and this is also something that has come up in one or two presentations before. That some of your companies were active in this like interactive type of big data analysis. And this is something that in the animal conservation topic we've been doing a lot. So we have been developing applications on tablets, for example, for identification of animals. So people could like click on the tablet to tell us where the animals were. And then we had a fully open and a cloud-based solution to basically make this interactively created data set interact with machine learning and computer vision model, and having this type of loops. I don't know if you see my mouse, but we have this type of loops here in blue that will feed back the results of the model to users that then can label more data and then make the models better, while the model may get asked for the most important information to the different users. So here again, I think that this type of human-machine joint technology is something that could be very interesting, because you work a lot of end users, customers, or people that evaluate your products, and that's maybe something where this type of approaches could be interesting. All right, and yeah, sorry, before moving to the second, so this is one application of the things that we are doing. Here we are detecting, counting, and tracking migratory birds on islands in the west coast of Africa, and we could effectively reduce the annotation time, so the time it took to ecologists to basically count all these birds, from 3 weeks to 4.5 hours. So the speed ups you can have with this type of interactive technologies are significant, and could be very efficient in your production line if this will prove interesting for some of you. Okay, the second application I wanted to talk about is ecosystem services, which is, I know it's a very broad term, and it could basically mean anything. This is like services that nature gives to people. And I decided to take this example because it's an example of a problem that is often very subjective and related to perception, because every person uses nature in a different way. And it's sometimes very difficult actually to measure these type of things, because they're very abstract. How can you measure cultural benefits? How can you measure interactions with nature through sports, for example? And the good thing is that to have this first-person view on this ecosystem services, we have a lot of data that come, for example, from social media or all kind of sensors that we can imagine putting out in the landscape. And the question here was, can we extract from social media data that are very noisy and very difficult to handle because they are heterogeneous, some are text, some are images, and so on, can we learn something about subjective perception of something related to nature? So yeah, I underline here the subjective perceived aspect. It's probably something you face when you think about marketing and things like that. And in this example, we were working on landscape enjoyment, and then we were working on a kind of a game where people were asked how much they liked a landscape that they were seeing on photos, and we were trying to make a map of actually where the nature was considered enjoyable and where people were going to enjoy it. And so we gather a number of different sources of data. So you can see here we have some pictures from social media. We have some data that come from satellites. Some come from OpenStreetMap, so where the locations of, I don't know, restaurants or monuments, things like that. And we use a number of computer vision technologies to extract a number of descriptive characteristics of these places. So would that be objects that appear in the image, type of scenes, environmental indicators, and so on and so forth. And then we used a number of machine learning technology to put all this together to finally have a score that will tell us this place is enjoyable or this place is not enjoyable. And this is interesting because not only then you get a score of the enjoyment, which per se can be interesting when you do economic valuation of landscapes, but actually it allows you to go into explainable artificial intelligence. Because since we went through all these intermediate factors over learning, we were then able to use all these factors that are understandable by people. And we could say, okay, this image is considered enjoyable because it has to do with climbing, because it's natural, and because there is some ice, and people tend to associate that to positive feelings and things like that. So we had a kind of a window of interpretation inside what the neural network was doing, and this basically allowed us to put something that was understandable into the prediction of a model, of a deep learning model that are often a bit cryptic and difficult to interpret. And then we scaled all that up using satellite data, and then we were able to having like a map of enjoyment of the whole of the UK. And this was basically a way to integrate different types of sensors, some of them being images, some of them being social media based, and then working all of this together in order to have this type of large scale mapping. The third and last application I will talk about, I see I still have 3 minutes, is the time series analysis. And here I think I have an example that maybe you can relate to a little bit more. So in this application, we were working on time series of satellite images in order to identify crops. So this is like in this idea of digital agriculture, and we wanted to basically, for each crop, having it observed every 2 weeks or mostly every 10 days by the Sentinel-2 sensor to basically know what was being cultivated and when it was harvested. And then, so we had this time series. We have here an example for our rapeseed field. Here on the right, we have an example of a temporary meadow. And then we basically created a model that was taking the time series and then making basically 2 predictions. One, here on the right, is the prediction of which crop it is. And we want this to be as correct as possible, and having a score that tells you, okay, for sure, this is rapeseed, and this is temporary meadow. But you also see that these models sometimes make errors. So at the beginning, by looking at the first part of the time series, it thought it was wheat. But actually, we had a second classifier on the side that was basically telling something about the uncertainty of this prediction and telling us at which point of the time series the classifier was sure that the answer was the correct one. And so, as you can see, when the answer was wrong, the classifier was basically completely unsure. And this allowed us to basically make crop mapping at scale using this time series, and then having our answers. So you can see here 3 dates in time and the prediction of the model. And everything that is a little bit in transparency are areas where the model is not sure. But when they get sure, so these are all the fields that are in full color, then the predictions are the more often correct. So of course, models make error. Every machine learning method make error. If someone tells you the contrary, they're lying. And basically, by using this, you basically stop your decision at the right time when the model is sure enough. Voila, these were my 3 examples of things that we do. And I hope it will maybe sparkle some ideas and interest on your side. And I'm very happy to discuss later on. Thank you very much.